So it was kind of a review, didn't have everything, but it's still a good review, but only the odds. That's the one where you were putting them on the board and checking each other's work. So hopefully that's all done because we worked on it in class. But you don't have to do the evens.
So when you have only two different those equations being divided, only two, you use long division. But if you have four of those or two fractions with the equations, then you'd use the factoring right.
That's a good question. How do you know when to use both, or when to use which one? I think the exam is going to tell you when to long divide.
Oh, so just tell us use long division.
But what you said is right too. You're not going to long divide by two different things. You can't. That doesn't really work. You could only divide if there was one thing down there.
Also,
so your statement was right.
When you get your remainder from long division, if your remainder thing where it's the number over your original divider thing, if that thing can be factored, or would you factor it, or
So you only have to factor things if they will then reduce. But you don't know if it'll reduce until you factor it, usually. Or at least factor it in your head and see, yeah, that'll work, or no, it won't. So it's a good question with a weird answer of you only have to factor if it will reduce. But the caveat is you don't know if it'll reduce until you factor. Okay, on the review, this is what we'll work some of today. Again, I tried to split it up and get you to work some of it ahead of time so you don't have 30 problems to do tonight. I hope that's the case for you. I've picked some, so I'm going to work some, and then with whatever time is left, you can pick some, and we'll see what's left after that. Let's look at number 3. Okay, this sort of gets to Giant's question about long division. I could factor the bottom, take an x out. I can't factor the top, so I'd kind of be stuck. So the fact that it's telling me to divide, I'm pretty sure the only way I'm going to divide this thing is with long division. So let's long divide and see what happens. So something times x squared gets me to x cubed. That would be an x. So x cubed minus 2x squared. And then this next all-important step that sometimes people mess up. What do I do next? Change those signs. This one's nice that they both go away. Well, maybe that's nice. Maybe it's confusing. Because my next step would be what here times x squared would get me to 3x. You're like, wait a minute, that doesn't work. And in fact, that doesn't work means we're done. So that thing down there is the remainder. 3x minus 1 over x squared minus 2x. So my answer is x plus 3x minus 1 over x squared minus 2x. Hold on just a second, Giant. To your question from earlier, yes, I could factor the bottom, but I can see that the x or the x minus 2, neither will cancel, so I don't need to factor it. So I can leave it as is. It wouldn't be wrong to factor it, but there's no need to factor it.
Also, when you have a long division like that, where the first thing all cancels out to 0, do you just take all of the remaining, and just drop it down?
Yes. In fact, you can always take everything down. It's most of the time that's more writing than we want to do, so take as much down as you need, kind of. Alright, let's turn the page and do some of these. Let's look at number 10. Alright, so big picture, this is a subtraction problem. Which means, what do I have to have if I want to subtract? A common denominator. So let's work on our denominators and see if we can get them to be a common denominator. What do I see? I can take a 3 out of this one. So x plus 3 and x minus 2. Then we'll factor the second one. And remember that we're usually expecting them to have something in common. If they don't have something in common, then I have to multiply all of this by all of that, and all of this by all of that. And so they usually have something in common, which can help me with factoring. So I'm hoping that one of these two factors shows up again. Let's see, 2x squared plus 11x plus 15. Everything has to be positive, which means it's certainly not going to be x minus 2. Let's see if the x plus 3 would work, because that would sure be nice. And sure enough, 6 plus 5 is 11, so yeah, we've got our factors. And we have a repeated factor, so that makes finding the common denominator at least a little bit easier. So now we're the kids in the back seat of the car on the long trip in the minivan, Micah. So first kid looks over at the second kid and is like, hey, that's not fair. Why can't I have a...
x minus 2.
Oh, that would be this guy. But what does this guy want?
2x plus 5.
2x plus 5. And where do I put that 2x plus 5? Top or bottom? Good. Both of those places. So 2x plus 5. Top and bottom. And then Ella, the second kid in the back seat's like, wait a minute, that's not fair at all. Because I would like to have...
X minus 2.
Top or bottom? Both. Now, kids in the back seat, they're pretty observant. They don't mess around when they're getting shorted something. Is there anything else that second denominator kid would like to have? A 3. Top and bottom. Okay, so got the denominator figured out. That's the 3, x plus 3, x minus 2, 2x plus 5. So I can just write that as one denominator because they've all got the same denominator now. I'm going to write this step because people write this step and then mess it up. So I'm going to write it in hopes that it'll help us see what not to do. Can I cancel this 2x plus 5s right here? Why not? They're factors, kind of. It's like, well, the bottom one's definitely a factor. The top one is not really a factor. I mean, it's part of this term. It's being added, so I cannot cancel those. Same with the x minus 2. I can't cancel those. So what do I do? Multiply it out, combine like terms, and see if... Then we'll look to see if anything will cancel. So 8x squared plus 20x. Careful with that minus sign. We got to distribute all of that stuff over. Minus 6x squared plus 12x. So that would be 2x squared plus 32x all over all of that denominator. Oh, I boxed that, but did I box that prematurely? Because Giant's evergreen question once again. Do I need to factor the top? I mean, it can factor. Do I need to factor it? Why not? Because nothing would cancel. So you kind of like have to factor it in your head to see if it would cancel. I can take out a 2 and an x, but that wouldn't cancel with anything. It would leave x plus 16. That wouldn't cancel with anything. So no, I don't need to factor. At least I don't need to write it out, I guess I should say. All right, look at all the things that went into that. You had to know the concept of getting a common denominator. You had to be able to factor. You had to be able to FOIL. You had to be able to collect like terms, and then look for any other factors that would cancel. So a lot goes into those type problems. A lot of places to make a mistake. How about 11? What do we call that? Complex fraction. We got fractions in fractions. That's the one where there's multiple options. You can add the top, get that all cleaned up. I guess subtract. Then add the bottom, get that all cleaned up, and then do keep it, change it, flip it. Or, if you're careful, you can clear all those denominators. Grace, what would I need to multiply by if I want to wipe out all the denominators? So multiply top and bottom by 3x plus 2 and x minus 9. And if you're doing this the super safe way, you write out 3x plus 2 and x minus 9 on each of those 4 individual fractions. But the point of doing it this way is to avoid writing out all of that stuff. So let's do it in our head, one piece at a time. I need 4 different voluntold to help me out here. So, Giant, top left, just that top left fraction, what would cancel when I multiply by 3x plus 2 and x minus 9?
X minus 9.
And what would be left?
24x plus 16.
He's jumping a step on me, which is fine. I'm going to leave it as 8 times 3x plus 2, but what Giant said was right. Benji, how about the top right fraction? What cancels?
The 3x plus 2.
And so what's left?
X times x minus 9.
X times x minus 9. And again, if you want to distribute that sort of on the fly, you can. I'm just trying to show a couple of steps here. Ryan, how about bottom left? What cancels?
3x plus 2.
And what's left?
3x minus 27.
Sure. And Molly, bottom right,
X minus 9.
cancels, and what's left?
4x times 3x plus 2.
So we had a mishmash of distributing and not distributing, which is fine. But the whole point of that step was it's not a complex fraction anymore. It's just a regular fraction. So 24x plus 16 minus x squared plus 9x all over. Yeah, it would have been faster if I had let everyone distribute on the fly. Negative x squared plus 33x plus 16 all over 12x squared plus 11x minus 27. Oh, back to our favorite question of the day. Do I need to factor that some more? I don't know, because I don't know if something will cancel. I'm looking at the top, and there's no way I'm getting to 33, right? Because my only options are 1 and 16, 2 and 8, 4 and 4. So there's no way the top will factor. I mean, I guess I should take out the negative, but that's not going to matter. I'm not getting to 33 plus or minus, so the top won't factor. So the answer to does the bottom factor is we don't care, because it definitely won't cancel with the top. So is there a way to get 11 out of all these possibilities? Like, I don't know, maybe, because that's a lot of different ways to get there, but it doesn't matter because we can't factor the top, so why bother with the bottom? Giant.
What about like a long division?
Like a long division on this problem?
Yeah, would there ever be like on the test maybe?
No, we would not ask you to do that.
Yeah, So it will just explicitly tell you like which one it only wants you to use.
Long division for? I think it does. I think it says use long division.
Okay. So when it wants like the exact thing versus this simplify.
I mean, it's not going to walk. You have to know what to do when you see this problem. That's part of what's going on. All right, let's look at number 16. Still adding and subtracting, but somehow after doing the hard ones, people panic on what should be an easy one, or an easier one, I think. Having said that, let's put Andrew on the spot. Andrew, what's our common denominator going to be?
6x squared y.
Good, 6x squared y squared. Perfect. You got 3 popsicle sticks here. So, Ava, what's the first fraction need to get to that common denominator? 3y squared. Remember, these denominators, they're very demanding. They want to match exactly. Yeah, it needs an x in there as well. Top or bottom? Both. So 3xy squared. Dylan, now it's the second kid's turn to look around, and what does he want? Yes. And then Jacob, that last denominator, what would he like? Another x. Got to be fair. So 3xy cubed plus 8y cubed minus 5x. And then those are terms, not factors, so please don't start canceling weird combinations of things in there. People go overboard and they're like, oh look, 3 and 6, that reduces. Y cubed and y squared, no, those are terms in the top, and you can't cancel terms. Alright, the last one I wanted to look at is 26 through 30. It's a collection there. All go together. Although, you know what? Let's back up and look at 25. How are we going to do 25? It's going to have to be long division, because I can't factor this thing. I don't know what that is. I guess that the second one factors, but the first one doesn't factor. So the only way to do this problem would be long division. Okay, let's skip ahead to 26 to 30. It's been a while since we've seen these. Well, sometimes you get the easy question. So, Madison, I should get out of the habit of calling on people after I said it's an easy question, but Madison, how many total zeros does that thing have? 3. How did you know that? Yes. The degree, which is the greatest power. The only thing is, be careful, right? Sometimes we put these out of order to try to trick you, and so you've been tricked enough. Like, don't fall for that again. In behavior, Madeline, how about the right end? Right end is up. Let's see if we can remember how to write that the fancy way. I think on the test it's sort of filled in. So the right end would be x goes to positive infinity. That means our graph is going to positive infinity. Right, so that's the fancy way of saying the right end is up. Carter, how about the left end? What's it doing? It's going to negative infinity, so if we want to write that fancy, as x goes to negative infinity, that's the left side. P of x is going to negative infinity because that means down. Wait, how did you know it was going down, Carter?
It's opposite, the degree is opposite of, or it's a negative, or it's odd, so it's opposite the right.
Right, it's like 3 steps that you take in your head really quick. The degree is odd. Odd means opposite, and the opposite of up is down. So it's not hard, but it's like these 3 quick leaps in your brain that you have to make. Jeremy?
Can we write positive leading coefficient?
Positive leading coefficient would be why this one's up.
Can that be how you describe it?
No, describe the end behavior means I need, is it going up or down? The reason is positive lead coefficient. John?
All the solving ones on the test, will they all be like ones that we can easily factor and solve?
Yes, except for the ones that explicitly say use your calculator and round to the nearest thousandth.
For those, you just plug in the thing into the calculator and
Yep. Alright, find all the roots. Find all the roots. How would you like to find all the roots of this thing? There's 2 different ways, and I did it one way, and students did it a different way. What's up? Grouping. That's probably the better way. It's not the way I did it, but it's the better way. Because Madeline recognizes that, hey, look, that'll group x squared, that leaves x plus 2, plus 4, that leaves x plus 2. So x plus 2, x squared plus 4. So there's an easy answer, x equals negative 2. What about x squared plus 4? Yep, plus or minus 2i. So how many total zeros did we say we would have? And how many total zeros do we have? And then number 28, how many, or 29, how many real roots are there? And how many imaginary roots are there? Could we ever get 3 imaginary roots?
No.
Why not?
Because the imaginary roots have to be pairs.
Good. So there's your reminder that imaginary roots come in pairs, so you won't have 3 of them or 5 of them or 1 of them. You'll always have an even number of them because they come in pairs.
we have to know those like rules from last unit, like with the eyes, like those like theorems from the last unit.
I don't know what you're referring to.
Like you know they're like the theorems from the last unit where it's like I don't remember it.
Oh, they had fancy names, but basically it boiled down to I roots come in pairs. That was one of them.
So like we'll just have to know the like concept.
Yes. The other way we could solve this. So what if we didn't see that it factored and we remembered that we had a calculator? Oh, that's calculus in there. How would a calculator help me find those roots? What would I be looking for? The zeros. So another place where if you're using your calculator works. Whoop, that graph's in the wrong spot, so now I got to go change my window. Zoom standard. Well, that confirms that I've got 1 real root. And the table tells me that it's negative 2. This is the way I did it last period. If I know negative 2 is a root, what could I do with negative 2 to start to get more answers? I could synthetic divide. So I don't know that this is the best way, but it is a way. Hey, negative 2 works. Of course it does. And what we're left with is x squared plus 4, and that leads to those 2 answers. So Either way, factoring is probably quicker if you know how to factor. Okay, those were the ones that I wanted to work. Still 15 minutes left or so. Are there others in there that you saw that you were curious about? Either you tried or even just as we turned through them, you're like, ooh, I don't know what that one's about. 25. Oh, the long division problem? Yeah. X to the fourth plus 3x cubed minus 4x squared plus 2x plus 5. All the terms are there, but I'm mentally checking to make sure that I'm not missing anything, right? Because I'll need to throw in a 0 if I am. So something times x squared gets me x to the fourth. So x squared times x squared is x to the fourth minus 3x cubed plus 2x squared. Draw the line, change the signs. First term cancels out, because the first term always cancels out. And be careful, the second term looked like it was going to cancel out, but then we made it positive, so they add. 6x cubed minus 6x squared. Another question from earlier, like, well, how much do I need to bring down? I think just 1, but you can bring down all of it either way. Okay, something times x squared gets me 6x cubed. So that would be 6x. 6x cubed minus 18x squared plus 12x. Again, make sure you change all those signs. Draw that line and change that sign. 6x cubed minus 6x cubed goes away. That will always happen. We rigged that to happen. 12x squared minus 10x plus 5. On the subject of bringing things down, you can see that it doesn't really matter when you bring down the plus 5. Like, eventually it falls all the way there. And then something times x squared gets me 12x squared. This was a good one to do because we got three rounds of practice here. 12x squared minus 36x plus 24. Draw that line and change that sign. Hey, the lead terms cancel out. You rigged that to happen, right? That happens every time. 26x minus 19. And then, I guess 2 things happened at once here. I ran out of space, and what times x squared would get me to 26x? It's like, that doesn't really work. So what do I do with 26x minus 19? Yeah, put it over the divisor. Use the fancy word there. So there's my answer. If I remember right, there's a question on the test that asks just for the remainder. So that would just be this part down here. So make sure you answer the question that's asked.
Wait, so when it asks for remainder, you would put like exactly what's down that you want to put like that over the divisor?
Correct. The remainder is just the leftover stuff. To give the complete answer, you put the remainder over the divisor. But the remainder is just the leftover. Right? Like when you did 7 divided by 3 in 4th grade, you said that was 2 remainder 1. The remainder is 1, not 1/3. Yeah. Later in life you said 2 and 1/3, but the remainder is still just 1. Right? What else? Number 12. Yes. First period asked for 12 as well. So let's see. I don't have to factor anything. So I can just look for things that will reduce. Like 16 and 8 will reduce. 2 and 1. 15 and 27 will divide by 3, so that's 5 and 9. So my numbers are negative 10 in the top and 9 in the bottom. And then I start looking at my letters. So how many X's are left and where do they go? One on the bottom. We've done this enough time we can kind of skip a little bit here. Then I look at my Y's. It's got to be color coded or it doesn't work right. Oh, that's an easy one. Because there's one Y in the top. That's the only thing we got. And then lastly, the Z's. What's the net result of the Z's? 2 in the top. That would be another one where the calculator might help you. Negative 16 times 15 divided by 27 times 8. Like, ooh, I don't like that number. Let's turn that into a fraction. Negative 10/9. But if you know how to do all that in the calculator, you're probably fine doing it without the calculator. And the calculator actually wouldn't help with the X's and Y's, so. What other problems did you see that you weren't sure about? Get back to this. We hit all of these. Jeremy? Number 8. What's the negative 1 out, or that negative 1 do, Jeremy? Just flips the whole thing. So I'm going to flip it and factor it all at once. Dangerous life, but there's that one. Oh, I can take a 2 out of that. Don't leave the 2, right? The 2 goes with it, but I can factor out the 2. And then x plus 3, x minus 2. Nothing cancels yet, but surely there is more to come. 2x, x plus 2, x minus 2. There we go. Now I got things that will cancel. And then x plus 5 and x minus 7. And because everything is canceled or factored, now I can look for things that will cross out. Let's see, x plus 5, x plus 5, x minus 2, x minus 2. What about the 2x and the 2? Students sometimes get stuck on that one. Can you reduce 2x and 2? Oh, let's come out to the side. What's 2x divided by 2? Just x over 1, or just x. So I can reduce the 2x and the 2. I mean, the x will still be there, but the 2's will go away. So left over in the top, looking carefully at what's left over, x, x minus 1, and x plus 2. This is the type of problem where like one person per class will miss because they couldn't read their own writing. Like I'll see all the work is there, but because they canceled sloppy, they accidentally marked something out, and then they lost it from this step to the final step. So unfortunate. Jeremy?
Will it ask you what x can't be?
Oh, good question. So on this one, so x can't be this stuff, but because it's flipped, it can't be that stuff either. So that's sort of like the keep it, change it, flip it problem, where it can't be either one. And then anything in this stuff, so if I can keep track of where all those things were, preferably before I canceled them, but I can still see. X can't be 1, can't be -5, can't be -3, can't be 2, can't be -5, I already wrote that one down, and can't be 7. Okay.
So when it asks like what X cannot be, you have to look at the entire question for anything that was on the denominator.
Anything that was ever in any denominator.
Okay.
Yeah. But numerators are fine. So X could be 0, X could be -2, that's fine. But you can't divide by 0. Any of those values would have put a 0 somewhere in a denominator. All right, a bunch. I'm hopeful. We didn't do any of these factor only. Hope you're, although we did some factoring, so maybe that counts. Looks like some grouping on that first one. Jeremy?
On the test, when it says just simplify, do you want us to put what X can be, or do you want us to just, or will it ask us?
I think it will ask you. And remember that most of them are multiple choice, so it won't matter for those. I think it will ask when it needs it. John? So there's one on the review here. Box is to be constructed. Right, here's our box where we cut a corner out of each side, or out of each corner, and then we can fold it up to make a box. Right, done that a bunch of times. Write a function for the volume of the box. Okay, so length times width times height, that's not the final answer, but that's the volume of a box, so we'll start with that. If I cut off X from each end, how long is this length right here?
Good morning, Monday. Time for the daily note.
Minus 2X. We'll finish this in just a minute, but that's kind of the key to the whole thing right there.